So, I was thinking that I was finished with my videos for the night, and then I remembered that I need to do a video for the progress check. Alright. Unit 2, progress check D. First question. The function f is given by who? That thing right there. Where b is a constant and g is a differentiable function satisfying g of 2 is equal to 4, g prime of 2 is equal to -1. For what value of b is f prime of 2 equal to 0? So what you're trying to do here is first you need to find the derivative of f. But to find the derivative of f, you are going to have to use the product rule. The first function given here is 2x cubed plus bx, and the second is g of x. So you have to use the product rule. So the first times the derivative of the second, and the derivative of the second would just be g prime of x, plus the derivative of the first, and the derivative of that would be 6x squared plus b. And then you would multiply that by the second, which is g of x. So if you have f prime of x, you're now trying to find f prime of 2, but you won't be able to find a value for f prime of 2 because you have the constant b, but you can still plug in 2 for x. So you'd plug in 2 for x into f prime of x, but then you're going to be left with constants, and you're going to have some terms that have b with it. And then what you're going to do is you're going to set that all of that equation equal to 0, and then you're going to solve for b. So that's what you're going to do there. If that doesn't quite make sense, look at my key, and then hopefully I've explained it well enough where you can use my key to get you the rest of the way through if this isn't making sense, okay? Alright, the next one, the table above gives values of f and g and their derivatives at x equals 2. What is the value of d dx of f g at x equals 2? So you're just using the product rule. So use the product rule on f and g being multiplied together. The first times the derivative of the second plus the derivative of the first times the second. And then you're going to plug in 2 into all of those. And then you're going to get the values from the table and go from there. Okay? I realize that trying to speak about this probably isn't too helpful. So definitely probably, if it's not making sense, maybe listen to this and use the key at the same time. Okay, here, so we have f of x equals 1 over x times by cosine of x. Then f prime of x is equal to, so you can do this one of two ways. You can use the product rule using the product given there, or you can even use the quotient rule. You can treat it as the cosine of x over x, but I think I would just use the product rule. So the first, 1 over x, times by the derivative of the second. Derivative of cosine of x is negative sine of x, plus the derivative of the first. The derivative of 1 over x is negative 1 over x squared, and then times by the second, cosine of x. And then I think you're going to have to get a common denominator, because all of these expressions don't have two terms, it just has one term. This is all one singular expression. So, okay. Question 10, we have the function given there, f prime of 1. This one is going to be using the quotient rule. So low, d high. So the low meaning the bottom, d high meaning the derivative of the top, minus high, d low, high being the numerator, d low being the derivative of the denominator, all divided by the denominator squared. And then you're going to plug in -1 for x, and then you're going to get your answer. Okay, so for this one, the graphs of f and g are shown above. We have h of x, and we're trying to find h prime of 2. So you're going to use the quotient rule here, low d high minus high d low, square the bottom. And then once you do that, you're going to plug in 2. And you're going to use the graphs to find f of 2 and f of 2, g of 2, f prime of 2, g prime of 2. So f of 2, if you look at the graph, is equal to 3. G of 2 is equal to 4. F prime of 2 is the slope at 2, and the slope at 2 looks like it's 1/2, and g prime of 2 is the slope at 2 for g, and that looks like it's going to be negative 2. Okay? And then once you have all those values, you can plug them in and get your derivative. Question 12. What is the slope of the line tangent to the graph of that expression there? Okay, so I know tangent lines are kind of rough, but you need to do y1 minus y minus y1 equal to m times by x minus x1, the formula for our tangent line. Now we have x1, we're taking the tangent line at x equals 1, so we have that value, but we need the y value. So you're going to plug 1 into the function to get y1, and then we're going to need the slope, and we're going to get the slope by taking the derivative of y and evaluating that derivative at x equals 1. And that derivative is going to require the quotient rule. And then, yeah, you can find your answer there. Oh my gosh, one second, back up. This is just asking for the slope of the line tangent. So we don't have to create the tangent line. All we need to do is take the derivative and plug in 1. That's all we need to do. It's just asking for the slope of the tangent line, and that's just going to be the derivative at x equals 1. So, sorry, I misspoke. None of these answers here are equations. You don't need the equation. So, yeah, I just need to take the derivative and plug in 1, and the derivative requires the quotient rule. Alright, question 13. You're taking the derivative of cotangent of x. This should be very easy. You can look at your notes because the derivative of cotangent of x is just a simple rule that you guys are going to have to remember at some point, okay? So you can just do that. And then here we have d dx of sine of x times by cosecant of x, and this is pretty easy. You just have to know your trig identities. You have to know what cosecant of x is, and cosecant of x is 1 over sine of x, and then hopefully you can take the derivative after you simplify your expression like that, okay? Alright, that should be everything, so hope this helps.